Hello, algebra students. So we are going to jump into chapter 8. We're going to start looking at what we mean by a relation and what we mean by a function. So as I've said before, anytime you start a new chapter, you usually get a bunch of definitions, and this is no different. So let's just start with something kind of easy here. And let's say, for instance, if we were given a linear equation that kind of looked like this. Let's say y is equal to something like 2x minus 6. And let's say if you're asked something like, do the following ordered pairs satisfy this equation? All right, do the following ordered pairs satisfy this equation? So if this is the equation that we're talking about here, what we're going to do is we're going to get some ordered pairs or coordinate pairs, xy pairs, and we're going to kind of test them in there and see if we get a true statement. So let's say, for instance, if we had something like, say, 3, 0. Remember, your x coordinate's always first, y coordinate is second. So we want to take those things, put them into our equation, see if they work or not. So that is, if I was to let, say, y equal 0, looks like x is 3, so I'd have 2 times 3 minus 6. So 6 minus 6, we get 0 on both sides. So yes, this particular ordered pair does satisfy this equation. All right, let's say if I pick something else like, I don't know, let's say if I had something like, say, 2, negative 2. Okay. So if that is, if I was to put in y is equal to negative 2, I'm going to have 2 times x, which is positive 2, minus 6. So negative 2 is equal to 4 minus 6. Again, true statement. This one satisfies this particular set of ordered pairs. Okay, now let's try one more here. I know this is kind of boring here, but it is what it is. So let's say if the ordered pair that we're given here is, say, something like 1, negative 5. So I'm going to let y equal negative 5. I have 2 times 1 minus 6. So this is negative 5 is equal to negative 4. All right, so this set of ordered pairs does not satisfy this equation. So one of the things you have to realize is that if an ordered pair satisfies an equation like this, when we go to graph this thing, that xy pair is going to be on the graph. All right? So I think that's kind of worth writing out. So let me show you what I mean. We're going to say that the graph of an equation, all right, and let's say in 2 variables, so just x, y, 2 dimensions here, is the set. Oops, my mistake there, is the set. Let me try that again. Of all ordered pairs, those are our xy pairs, that satisfy the equation. Okay? All right, so I'm saying the graph of an equation, it's the set of all xy pairs that satisfy the equation. Now, let me kind of turn this around. And that is, every point on the graph will satisfy the equation. Okay? All right, so let's say if we wanted to graph something and we have no idea what it looks like. One way of doing this is kind of a process referred to as plotting points. So we're going to take an equation, we're going to pick some x values, we're going to figure out the y values, and kind of go from there. So let's say, for instance, if we wanted to graph, and again, I'm going to use a linear equation, something like y is equal to 3x minus 5. All right, so let's say, for instance, if I make some kind of little chart here. Ooh, let's see, my lines are kind of straight. There we go. So what I'm going to do is I'm going to pick some x values. We're going to calculate the y values so that we are going to have a set of ordered pairs. All right, so let's see here. So if I pick things like, say, -3, -2, -1, 0, 1, 2. And let's see if I can extend my line here, 3. I'm just kind of picking a couple x and y values, x values in a row. All right, so what we want to do is to, figure out what our y values are. We're going to take this equations, we're going to substitute in the x values and calculate the y's. So for instance, here I am going to have, this would be 3 times -3 minus 5, so that my y value is going to be -14. Sorry, I'm a little tight on space there. So this is going to be 3 times -2 minus 5. That's -11. 3 times -1 minus 5. That's going to be a -8. This is going to just be a -5. I should probably make this 5 look better up here. This is 3 times 1 minus 5, or -2. 3 times 3. 3 times 2. I got ahead of myself there. Minus 5 is equal to 1. And 3 times 3 minus 5 is equal to 4. So, as I said, I get a set of ordered pairs. So I'm going to have, say, -3, -14, -2, -11, -1, -8, etc. This is 0 minus 5. This is 1, -2. This is a 2, 1, and this is a 3, 4. All right, so this gives us a set of ordered pairs that we can put together and connect the dots. So what I did here is I put a graph grid here, and what I did was, because some of our numbers are on the big side, I have decided to put the y scale in steps of 2. So this would be 2, 4, 6, 8, and -2, -4, -6, etc. But in the x direction, I think we can get away with going in steps of 1. All right, so let's see if we can plot some of these points here. So my first one is at -3, -14. So 1, 2, let's see, there's 0. 1, 2, there's -3, -14, -2, -11. We'll kind of estimate there. -1, -8, 0, -5. X is 1, y is -2. When x is 2, y is 1. And we're at 3, 4. All right, so let's see here if I was to kind of connect the dots here. Let's see if I can do this without messing this up. Hey, that's not bad. That is not bad. Not bad at all. Okay, but obviously we got something that's a straight line. We got something that's a straight line. All right, now there are a couple of points that I wanted to kind of point out to you, but I think I'm going to do it on my next graph instead of this one. All right, so let's kind of try one more here where we're going to be plotting points. All right, so if that is the case, let's say if we wanted to graph something that looked like this. Let's say if I wanted to graph something that looks like, say, y is equal to, let's say, 4 minus x squared. So what I'm going to do is, again, I'm going to make another little table here. And we're going to pick some x values. We're going to calculate the y values. We're going to generate a bunch of xy pairs. And let's see if I can make this a little bit longer. There we go. All right, so x, y, and then our ordered pairs here. I know she was saying, how does she know what to pick for x? Well, I just pick, kind of reasonable numbers. I tend to do them all in a row. And the reason I do that is I think it's a little bit easier to see patterns if you do that. So now if I let x equal -3, I am going to have 4 minus -3 squared. So that's going to be 4 minus 9, or -5. All right, let's say if I had 4 minus -2 squared, so that's 4 minus 4, or 0. So I'm generating these ordered pairs here. 4 minus -1 squared, that's going to be 3. 4 minus 0 squared is just 4. All right. Now let's move down here. So 4 minus 1 squared is 3. 4 minus 2 squared is 0. And 4 minus 3 squared is -5. Okay, so the thing is, you may notice that some of my y values are being repeated, which is absolutely fine. That is absolutely fine. All right, so again, I put in another graph grid here. You don't need to watch me do that. It's kind of a painful process because sometimes I mess things up. So that's why I kind of stopped recording, and I just did something weird there. All right, and so that we can graph this thing here. So let's put our points in here. And in this case, because the numbers are not so big, I think we can go in steps of 1, 2, 3, and also in steps of 1 in the y direction as well. All right, so when x is -3, let's see, 1, 2, 3, y is -5. So we're down here. We're at -2, 0, -1, 3, 0, 4 up here. And then, as I said, my y values start to repeat themselves. So now if we were going to kind of connect the dots here, this is not a straight line. This is what is known as a parabola. We're going to spend a lot of time looking at those in Chapter 10. Now, a couple of points I want to bring to your attention, and that is, all right, so that is one right here, and this one, and this one. So these are places where we're crossing one of the axes. These are the x or the y axis. So these points that I have here, this is at, this is at 0, 4. And this is what is known as our y-intercept. This is where our graph crosses the y-axis. All right, it is this point right here. Now, when you are crossing the y-axis, no matter what you're graphing, whether it's a line, it's a parabola, it's a whatever, your x-coordinate is always going to be 0. So if we look at our last one up here, here it was. This was my 0, -5. We're crossing the y-axis, x is 0. Now these here, this is an x-intercept. this is an x-intercept. Okay, so in these two places here, and those are going to be this one and this one here, notice my y value is 0. So when you are crossing the x-axis, your y value is 0. Okay, doesn't matter what you're graphing, that's always going to be the case. Okay, now I know this is kind of dry, this is kind of dull, but when you're looking at section, this is all in section 8.1, all in section 8.1. Now, before we go on to 8.2, and I guess I should kind of label this up here. Oh, I did, my goodness. Before we go on to section 8.2 and 8.3, I need to kind of look at a definition of something, because it's going to come up in a number of places. And what we need to take a look at is what is known as interval notation. Okay, interval notation. Now, it pops up when you're looking at inequalities, and also when we start looking at functions and relations and what happens in chapter 8. So let's say, for instance, let's start with an inequality. If I had something like, for instance, say x is greater than or equal to 3. All right. So if I had a number line, all right, let's see if I can draw a number line. I wish I hadn't used that color, but that's okay. Here's my number line. All righty. Now, if I have, say, x is greater than 3, so let's say if this is 0, 1, 2, 3. If I wanted to kind of illustrate on my number line what x greater than or equal to 3 is going to look like, I want all the numbers beyond 3. Now, the way you want to read this is x is greater than or equal to 3. So that means 3 is included. Now, some textbooks use the open dot, close dot idea, which is fine. This one kind of uses what I refer to as the square brackets and parentheses. And the reason I kind of like that model better is because if you take this picture or this inequality and you want to write this in interval notation, if you can draw the picture, you can write interval notation. So right underneath this picture, I basically want all the numbers from 3 onwards. So from 3 to infinity. There's our symbol for infinity. Okay. Now, infinity is not a definite number. You always have a parenthesis at this end. But here, since I'm saying that the 3 is included, we use the square bracket. All right, let's try something else here. All right, let's say if I had something like, instead, y is greater than -2. All right, so let me draw my little number line, not in this goofy color here. Let's try something else. Let's just try kind of gray here. So I'm drawing my number line. Kind of looks like a pencil, doesn't it? Let's try that again. All right. And one going this way. All right, so if that's the case here, let's say if here is 0, -1, -2. So y is greater than -2. So I want all the stuff beyond -2. All right, but because this just says greater than, that means that the -2 itself is not included. So to let everybody know, we use a parenthesis here. As I said, if you're more familiar with the open dot, close dot idea, this one up here would be a closed dot, this would be an open dot. Okay, so if I'm going to write this in interval notation, I want to go from -2 to infinity, parenthesis, because it's not a definite number, but because I have a parenthesis here, I'm going to have a parenthesis here as well. All right, let's try a couple more here, because this pops up in a number of places here in chapter 8 and other places as well. So for instance, if I had, say, z is less than or equal to 4. All right, let me draw my lovely gray number line here. All right, and let's say if this is, say, 0, 1, 2, 3, 4. So z is less than or equal to 4. So we are going to go this way. Now, because this is a less than or equal to, we are going to put a square bracket there. That means that the 4 is included. So I want all of the numbers before 4 and including it. So I'm going to start at negative infinity up to and including 4. Now, some of you who are a little bit more observant might say, okay, well, wait a minute. Why is the infinity on the right side here, but the negative infinity is on the left side here? That's a really good question. And sometimes people get interval notation written backwards. Now, this is why I like using the number line picture, because if you can draw the picture, you're usually going to get the interval notation correct. Because if you look at my picture here, the 4 is the right endpoint. Up here, the 3 is the left endpoint. So that means it goes on the left side of the interval notation. Here, 4 is on the right, it goes on the right side of the interval notation. That's how you tell. Okay, so let's do one more here. And let's say if I had something like, oh heavens, y is less than -3. Doesn't even matter what this number is here. Okay, so if this is at 0, -1, -2, -3, I'm going this way. Now, I want all the numbers before -3, but the -3 is not included. So in the interval notation, what this is going to look like is from negative infinity up to, but not including, -3. Okay. So let's try one other thing here. Let's say if you're given the picture, can we write the interval notation and maybe the inequality that goes with it? So for instance, what I mean is this. Let's say if I had something that looked like this. All right. Let's say if this is 0, 1, 2, 3, 4, 5, -5. So let's say if the picture you're given is this. All right, so this is the part that is given. So if we were going to write the interval notation that would match this particular picture, well, I've got the -5. It's included because it's the square bracket. And we're going to the off to the right. So this is going to be from -5 onward to infinity. So if I wanted to write the corresponding inequality that would go with it is I would have something like x, or whatever letters your favorite today, is greater than or equal to -5. All right. Let's try one more where you're given the number line graph. And see if we can come up with the inequality and come up with the interval notation. All right. That's not what I wanted. Let's see here. Okay, so let's say if this is 0. Let's say if this is 5 and this is 10 here. So let's say, for instance, if I have something that looks like this. Okay, so the 10, if you look at this, is on the right endpoint of my interval notation. So, or on my number line graph. So that means he's going to be on the right side of my interval notation. So the 10 is going to be here. Looks like he's included, and I want all the stuff that came before that. So that's going to be the negative infinity. So if I wanted to write the inequality that would go with that, it'd be y is less than or equal to 10. All right, so as I said, a lot of this pops up in sections 8.2, 8.3, etc. All right, so let's see here. Let's actually kind of wander into section 8.2. 8.2 is really kind of short. And what section 8.2 has to do with is what are known as relations. All right, so section 8.2, and this is what we mean by a relation. All right, now if we were face to face, I would probably do 8.2 and 8.3 right together, but we're not, so we're going to have to kind of segment this out. So what do we mean by a relation? I'm going to kind of give you a definition, and then I will eventually look at what a function is very shortly, and their definitions are very, very, very similar. Okay, so here's my abbreviation for definition. We're going to say that a relation is some books use the word correspondence or rule. I like to use the word rule when, or I should say where, elements of one set, this is called the domain, all right, are assigned to one or more members of a second set and this is called the range. Okay, so relation is a correspondence, or I like to use the word rule, where elements or members, if you like that word better, of one set are assigned to one or more elements of a second set, and that second set is called the range. So kind of your input is the domain, kind of your output is the range. So we could say that our input set is the domain and the output set is the range. Okay, so your domain, you want to think of this, these are going to be your x values. The range, this is your output, these are going to be your y values. Okay, now, excuse me, when you're talking about a relation, and I'll be perfectly honest, most of the time we're going to be dealing with functions, but I sometimes like to illustrate a relation with something kind of simple. And that is, let's say if you're talking about, if we have what is known as our domain here and our range. Okay, and this is my sister here. She happens to have 3 sons. So if she's the domain, kind of what she's assigned to is her 3 sons. So she has a son who's named Isaac. She has another son. The last 2 are twins, who's named Corey. And her 3rd son is named Courtney. Okay, so if you're thinking about this as our domain, the range, the things that she's assigned to are her children. All right, so one thing in the domain could be assigned to one or more things in the range. Now, sometimes when you're looking at the graph of something, you can kind of figure out what's the domain and what's the range. So for instance, let me kind of go back to one of the pictures we drew a few minutes ago, this graph here. Now, when you look at this equation here, your inputs, those are the x values. That's your domain. Can you think of anything that we shouldn't put in for x? Is there any restriction on what we put in for x? I don't think there is. Because our graph is going to continue down this way. You know, we only drew a portion of it, but it's going to keep going and going and going. But I really don't think there's any limitation on what we put in for x. All right? So what I'm trying to say here is if I had something like an equation like this, so where we had y is equal to 4 minus x squared, our domain, as I said, think of this as your inputs. These are your x values. There, in this case, we could say there's no limitations. So what I can put in for my x values is going to be from negative infinity to positive infinity. Now remember, the range, these are your outputs. This is going to be your y values. If we look at my graph again, and we look at this kind of carefully, does this look like the very highest point on the graph? It looks like all of my y values are going to be from here going downward. And I would agree with that. They're going to be from here going downward. So if that's the case, when we go to write the range, this is going to be the top point or the highest value. So when I go to write my range of this, I could say it's going to be from negative infinity up to and including 4. Okay, I know that's kind of slick there, and that's kind of new, but from negative infinity up to and including 4. Okay, so let me draw one other thing here, and you're going to have to put up my really bad drawing ability here because it is really, some days, just terrible. All right, so let's see. Is this going to let me do this or not? Can I move this over? Nope, I can't. Let me get rid of that. I thought I did a pretty good job of that little oval. I guess I was wrong. Let me try it one more time. As I said, I'm not very good at it. I have no idea what happened there. All right, let's try this one more time. You know what? I'm going to leave it right there. And I am going to put some values on this. So this is kind of an oval or an ellipse. So let's say, for instance, this goes from here, which is at 0, 0. I'm going to use this one here. Let's say if this is here at 3, 2, this is down here at 3, negative 2, and let's say if this point over here is 6, 0. Now, let's say if I was interested in, we're just looking at this ellipse here is what this is called. We will get to those in chapter 12. Anyhow, kind of an oval. So if we were interested in our domain and our range here, so that is kind of where do your x values start and finish. So if I was looking at my x values, well, they go from here to here. That's it. It's going to be from 0 to 6. And I am including those endpoints because they're part of the graph. Now my range, this is the y values. Well, your lowest y values there, your highest y values there. Your y values are going to go from negative 2 to positive 2. So sometimes you can figure out the domain and range of something just by looking at the graph. So I think this is a good place to kind of stop for now, and then we're going to pick up and go into section 8.3 because it really does go hand in hand with this one here.